So after discussion of the major part of charged particles, that the amount of charged particles required to make 1 coulomb of charge and what is the charge on a single electron and what is charge actually, let us come forward to the main topic of this chapter, that is electric potential. Okay, so what is use of this electric potential? Let me tell you the definition first. That is the work done in moving a charged particle from infinity to the point at the same charge field. Okay, now some students are going to ask me, ma'am, we haven't seen infinity yet. What is infinity here? Okay, let me tell you students that infinity here and in science or mathematics, that is specified that infinity that is not in our reach. Beyond that we cannot reach. This is the limit. So the limit of any kind of charged particle is the infinity for it. Okay, so bringing any kind of charged particle from the infinity to the same field will gives you the electric potential of it. So here let us discuss the word potential first of all, and then we will move forward. What is potential here? Potential you can say in Hindi like it is takat. Okay, so what is the work of here as a charged particle? Anything like in your day-to-day life also, students, you have seen that doing in some work will need some kind of energy. Yes, am I right? So here also, to moving a charged particle from one place to the another place will require some potential. Yes, I think now you people got to know about potential word. Let me explain that with an example. Let us having two buckets, one is blank and one is filled with water, and there is a wall between them, and that wall is not open right now. Okay, so can you people tell me that is the water applying any kind of pressure downward direction? Yes, of course. So that pressure is required by the particles of the water. Yes, definitely there are too many particles and they all are pushing each other in downward, and the surface of the wall also, surface of the container also. So we can say that here the water level providing any pressure in downward direction. So here we can say that this pressure here is actually a potential of water, that the potential of water is making a movement in a water molecule. Definitely, that pressure can make the water molecule move from one bucket to another bucket. Definitely, yes. And if we open the wall, they will move slightly from one bucket to another till the level of both of them become equal. So we can say that for the pressure or potential, one should be at high position, or we can say high level, or we can say high potential, and one should be at low potential. So every time a water molecule here in this case will move from high potential to the low potential, or we can say high pressure to the low potential, low pressure. Okay, in same manner, electric charges also will move from high potential to the low potential. Okay, that you make to know that why high potential. What is high potential here? Earlier you remember that in case of insulator, I have told you in example of static charge that these electrons will come over the surface of the insulator. Fine, and whenever they get a way to move in the direction where there is a low zone or a zero zone. Yes, remember that? So here in this case, the insulator here where the charged particles are present is known to be as the high potential, and whenever they are getting a chance to move from there to the zero balance, that is low actually. Okay, so whenever a charged particle make movement from high potential to the low potential, that makes electricity actually. So there is a major role of potential here. The bulk of charged particles present anywhere gives you high potential, and the zero of any kind of charged potential at any place will gives you the low potential area. So charged particle will move from high to low. I hope you got to know about the term potential with the example that I have told you right now. Let me explain you with the diagram, with the help of this diagram right now, the definition of the electric potential again. Okay, so what we have learned, that the work done in bringing the electron or any charged particle from the infinity to the electric field, to the same charge electric field. So here is the example that the electron is here and that is actually at the infinity level. So what is infinity here? Beyond the boundary. That I have shown you the boundary area also here. So beyond the boundary, everything is infinity for it. Even 1 point slide towards the outside the boundary is the infinity for this charged particle. Okay, and bringing to that electron to this electric field, any point, anywhere, will gives you the electric potential of that point only. Okay, let me tell you again. Okay, see, if this is the area in the same diagram like we have shown here. So electron is here and bringing it here at this point P1. Okay, so work done is calculated from this boundary only. Okay, you are not going to calculate the work done from here. Why? Because electrons here and electric field here that is made by these electrons are actually repulsing this electron. You know that negative and negative repel each other. So in the same manner, whenever this electron wants to come to this electric field, it will get repulsion force. Am I right? Yes. So it will get repulsion force from this boundary only. It will not get here. From here, starting from here, it will getting the force of repulsion. Fine. Okay. So the work done we need to require. We are going to push it like go to this point. Fine. So we need to do work done here on this electron. So from here we are going to do work done and bringing this electron till this point. So till this point, whatever work done is required in bringing this charged particle will gives you the electric potential. In the same manner, if I am going to tell you, like if this electron again is going to come to this point P2 right now. Okay, so electric potential for this P2 will be different compared to the P1. So here we can say that electric potential is actually, according to the previous diagram, we can elaborate the definition in a more different way also. So we can say here it is mainly a work done by a charged particle to move in an electric field. Yes, I have elaborated you with the example of P1 point and P2 point, right? So P1 point gets you different potential and P2 point gets you different potential. So moving a charged particle in an electric field gives you different values for potential.